Hi, 6th graders. This is Mrs. Gall. Today we're going to talk about slope-intercept form. Please get your notebook ready and press play when you're ready to continue. Slope-intercept form is when an equation is set up like this. Y is set equal to mx plus b. Will you please write that down, and then we're going to go through what each of those pieces mean. Remember that m is always represented for slope. So that will usually be a number that we see there, and it will be telling us what the slope of our line is going to be. The b is always going to be the y-intercept. Just a reminder from previous lessons, the y-intercept is where our line crosses the y-axis. So if we're given an equation in slope-intercept form, we're able to graph our line because we know these two very important pieces, and we're going to go through how we graph that line throughout this lesson. If you were to go ahead and solve for x and y, you'd be able to find the y coordinate and the x coordinate. You will, in a typical year, have to memorize this. Let's go through and just identify the slope and the y-intercept in a few different equations here. So what is the slope of this line? Just a friendly reminder, slope is always going to be attached to that x. So what value is attached to that x? 1/4. So the rise would be 1, the run would be 4. What would our y-intercept be where this line crosses the y-axis? That would be 6. Positive 6 is important to note there. Let's try this one. What would our slope be? Slope would be 3 or 3/1. What would our y-intercept be? Not just a 2, but a -2, because we have a minus out in front of that 2. And let's talk about this one. What would our slope be for this line? -2. Now we don't see a value there for the y-intercept, so what do we assume the y-intercept is? If we don't see a value there, we assume it's 0, so this line would cross at the origin 0, 0. Let's go through how we can graph an equation now if it's in y-intercept form. So you might want to kind of get a coordinate plane from your teacher or sketch one in your notebook so you can practice this graphing process. Go ahead and write down this equation. First thing we want to do is start at our y-intercept. That's kind of our starting point. So what is our y-intercept in this equation? +3. That's where this line is going to cross the y-axis. So that's where we're going to start. Now we're going to graph our slope from that y-intercept. So we're going to count the rise and the run of the slope to make a second point. My slope is -2, 3, -2/3. So my rise is a -2, so I'm going to drop down 2. My run is a 3, so I'm going to go forward 3, and I'm going to make a point right here. My line should be going in a downward direction because this is a negative slope, and it is. From there, I can go ahead and just count another rise over run to graph a second point. We usually want to see 3 total points in our line. We could also go back to the original point and go the opposite direction, up 2, backwards 3. That still creates that negative slope. Once we have 3 points, we go ahead and connect the dots and draw our arrows on both sides. Let's try another example. Y equals 5/2x minus 1. Just like with the last problem, we want to start by graphing the y-intercept first. What is our y-intercept? -1. So let's go ahead, find -1 on the y-axis and put a point. Now we're going to go ahead and graph our graphs using our slope for our second point. So we're going to identify slope 5/2, and it's a positive slope. So our rise is 5, so we're going to go up 5, 1, 2, 3, 4, 5. Notice I went up 5 from my red dot. And then run is over 2. 1, 2. We can from here go up 5 over 2 again, or we can go back down to the original point, and we can go down and back because that will still create a positive slope. So we could go 1, 2, 3, 4, 5, and then back 2, 1, 2. Since that was a double negative, it makes it still part of that positive slope. And then we can create that line by connecting our 3 points. Again, we really want to see 3 points. If we would have gone up 5 over 2, we would have just been off the graph a little bit, but that's okay if you wanted to continue your line that way. Y equals negative or positive 2x minus 4. First, we want to graph the y-intercept. The y-intercept is negative 4. So on my y-axis, I put a point at negative 4. From that y-intercept, we now graph our next point using slope. What is our slope here? I see a 2. What is the rise and what is the run if we have a whole number 2? Just a friendly reminder, when you have a whole number, it's the same thing as that number over 1. So the rise for 2 would be 2. The run would be 1. So we would go up 2 over 1. From that point, we could go up 2 over 1 again, or we could go back to that original point and go down to backwards 1, because that's a double negative, so that still creates a positive slope. Connect your 3, or in my case 4 points, and that would be your line. Let's look at a few where kind of some different things happen with our linear equation. So in a situation like this, y equals negative x plus 3. The y-intercept is pretty straightforward again. It's positive 3. So we would start by wanting to graph our y-intercept at positive 3. And then when I go to look at slope, I don't see a number in front of x, but I do see a negative. So what number is in front of x if we don't see one? Remember, there's always that invisible 1. So this would be negative 1x. What is that as slope for rise and run? Well, 1 is the same thing as 1 over 1. So this would be negative 1 over 1x for our slope. So from our y-intercept, we want to go down 1, forward 1 to create that negative slope. We could also go back to the original point and go up 1, backwards 1 to create that negative slope as well. And once we have 3 points, we can connect them. So if we have an x and there's no number in front of it, there's that invisible 1, which is the same thing as 1 over 1. Okay, y equals 1/4 x. What are we missing in this example? Oops, sorry. We're missing the y-intercept. We talked about this in one of our examples when we were just identifying. If we don't see a y-intercept, what must it be? Since there's absolutely nothing there, it has to be a 0. It's not like our x where we have the x, so there's 1. There's nothing there, so that's a 0 for our y-intercept. And now when we go to look at our slope, it's 1 over 4. So I put a point at 0, since there was 0 for our y-intercept, and now I go from 0, the origin, to graph my slope, which is rise 1, run 4. I can go back to the original point and I could go the opposite direction, down 1, backwards 4, and that would create my line. How can an equation tell you if the line is increasing or decreasing? One thing you can look at is your slope. If your slope is positive, your line will be increasing, going up. If your slope is negative, your line will be decreasing, going down. Okay, which lines look the steepest versus which lines look the most flat? That all has to do with your slope. So the higher the run compared to the lower the, the higher the rise compared to the lower the run, those are going to look steepest. The ones that are going to be more flat is when those numbers are closer together. Slope indicates the steepness of the line because we have our rise over our run. And so depending on how close together those numbers are, it's going to indicate how steep our line is. All right, you guys, that's all I have for you today. Check in with your teacher if you have any questions.